Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 9.14. So in this problem it is given that for the beam and loading shown, knowing that A is equal to 2 meter, W is equal to 50 kilonewton per meter and E is 200 gigapascal. So determine the slope at support A and deflection at point C. So you can see this is the beam. There is a uniformly distributed load between A and C, and this is W. Total length is 6 meter. The cross section of beam is given, which is W310 by 38.7. So let's start with the given data. So it is given that W310 by 38.7. Clear? So length of the beam is given as 6 meter. Clear? A is also given, which is equal to 2 meter. Uniformly distributed load W is equal to 50 kilonewton per meter. Modulus of elasticity E is given as 200 gigapascal. Clear? So what you have to find is the part first is that slope at support A. So at point A you have to find slope, which is theta A. Clear? At x is equal to 0. And in part B it is given that deflection at point C. So you have to find deflection at point C. It means that x is equal to A, which is equal to 2 meter. So let's start with the solution. Okay, so first of all, you know that this is the beam, so you have to draw the free body diagram and to find the unknown reaction forces at point A and point B. So let me draw this beam. This is a beam. This is point A. So at point A the reaction force will be RA, and at point B the reaction force will be RB. Clear? There is a uniformly distributed load W, which is at a distance of point A. Clear? And this W is equal to 550 kilonewton per meter. Clear? So in order to convert this uniformly distributed load into concentrated load, so you know that you have to multiply W with A and it will be converted into concentrated load. I will represent over here, or let me draw it separately quickly. So this is same RA, this is RB. Clear? And this W will be converted into point load and it will be W into A, and it will be acting at a distance of A by 2 from this point A. Clear? So now you can apply using free body diagram. Free body diagram of beam AB, ACB, CB. Clear? So you can see that this RA plus RB will be equal to W into A. Clear? Now this equation is due to sum of all force along y direction is equal to 0 and upward is positive. Now we will apply the second equation, that sum of all movement about point A is equal to 0 and taking counterclockwise as positive. So you can see one movement is WA into perpendicular distance, WA into perpendicular distance A by 2, and it is clockwise, so it will be negative. Clear? And the second movement is RB into perpendicular distance is total L. Clear? So it will be plus RB into L. their sum must be equal to 0. So when you solve this, you will have RB is equal to WA square over 2 uh, WA square over 2, it will be there, and divide by L, it will be this one. Clear? R, you can say that if you consider, you can see length is equal to 6 meter, L is equal to 6 meter, and A is equal to 2 meter. So it means that length is equal to 3 times A. Clear? So we can also write W into A over 2L. Now instead of this L, I can put 3A, so it will be equal to WA square over 6A. 6A. So RB will become equal to 1 over 6 WA. Clear? Now you have RB, you can put here RB and you can find out RA. So RA will be equal to 5 over 6 WA. So these are the reaction forces that we find out by using equilibrium method. Now next step will be that in order to find slope and deflection, we will take the section the beam at this point. Clear? And again at this point as well. This is section 1 and this is section 2, because where we have been asked to find the slope at point A and deflection at point C. Now if we use boundary conditions, so at x is equal to 0, y is equal to 0, and here at x is equal to L, y is equal to 0. So we do not have any other boundary conditions. So as we are interested to find out the slope and deflection at point A, so at x is equal to A, we have y is equal to y, which is deflection, and theta is equal to dy by dx, which is not known. Clear? So again, that's why we are using two portion of the section, which is 1 and 2, and we will apply the boundary condition in order to find the unknown. Clear? So let move and take the section at this one, which is at a distance of x. Clear? So I will first draw it over here. So this is the beam and some portion of the beam. This is reaction force RA. Clear? There is a uniformly distributed load which is equal to W, and it is acting at a distance of x. So if you cut the beam over here, so there will be a shear force V and there will be a reaction bending moment. Let this point is point J. Clear? So this is the portion of beam for which x is greater or equal to 0 and less or equal to A. Clear? So we will use first this. So we will apply the equation that sum of all moment about point J is equal to 0. So you can see there is a moment, reaction moment M acting, which is equal to M, and there is a moment due to RA into X, and it is clockwise, so it will be minus RA into X, and one is due to this distributed load W, and it will be converted into point load, which will be W into X, and it will be acting in the mid. Clear? So it will be at a distance of X by 2, and it is producing a counterclockwise rotation, so that's why it will be plus. So it will be W into X by 2. Their sum must be equal to 0. So from here you will get this reaction moment, and this moment will be equal to Ra into x minus 1 over 2 Wx square. Clear? Now you will have to apply the equation of this equation, which is equal to Ei into d square y or dx square is equal to m, and this moment is equal to Ra into x minus 1 over 2 Wx square. Clear? Integrating it for the first, you will get Ei into dy by dx will be equal to 1 over 2 Rax square minus 1 over 6 Wx cube plus C1. Clear? Okay. Moving further, again we will differentiate this equation. So we will have Ei into y is equal to 1 over 6 Ra. It will be 1 over 6 Ra x cube, and it will be 1 over minus 1 over 24 Wx 4 plus C1 x plus C2. Clear? Now we will apply boundary condition. Let this is equation number 1 and this is equation number 2. So you can put boundary condition at x is equal to 0. We have y is equal to 0. So put it in equation 2. So when you put it in equation 2, so y will be 0, all x will be 0. So we will get C2 is equal to 0. Clear? And at x is equal to a, we have C2 is equal to 0. So it means that this equation will be the same like this, and this equation will be only till this term. Why? Because C2 is equal to 0. Now we do not have any other boundary condition, so that's why we will move toward the sectioning the beam at point 2. So we will take the section at point 2. So let this is the distance of this distance is x. Clear? So we will take this remaining section. So I will draw the free body diagram of remaining section. So this is RB. Clear? As total length is L, this is x. So this distance will be equal to L minus x. Clear? So it will be, this distance will be equal to L minus x. And again, if you cut the beam over here, there will be a shear force in upward direction V, and there will be a reaction moment M. Clear? Let this point is point K. Clear? And this is the second section that is valid for x is greater than or equal to A and less or equal to L. Now we will apply the moment equation for this. So again, sum of all moment about point K is equal to 0. So you can see there is a moment which is clockwise, so it will be minus M, and due to this reaction force RB, the perpendicular distance is L minus x, and it will be counterclockwise, so it will be plus RB into L minus x. Their sum must be equal to 0. So we have this reaction moment is equal to RB into L minus x. Now this is the equation you will have to put in the equation, which is EI into d square y over dx square is equal to moment. Why? Because this is equation, this is the equation which will be used to find out the deflection and slope. So m is equal to RB into L minus x. If you integrate it for the first time, so you will get EI into dy by dx will be equal to minus 1 over 2 RB minus 1 over 2 RB into L minus x whole square. Clear? Plus C1, sorry, C3, because C1 and C2 are unknown constant, and here there will be another unknown constant, that is C3. If you integrate it again, so you will get EI into y is equal to my 1 over 6. Sorry, this is plus value, not minus, because you have two. So this is 1 over 6 RB into L minus x whole cube plus C3x plus C4. Now this is equation number 3 and this is equation number 4. You can apply the boundary condition. We have second boundary condition is that at x is equal to L we have y is equal to 0. So put in equation 4. Clear? So y will be 0 and x is equal to L. This will be 0. So only we will have equal to C3 into L plus C4. So C4 will be equal to minus C3 times length. But here again you can see you cannot find C3, C4, C1 as well. So what we will do is that we will have a boundary condition. I will show you that at x is equal to a, we have y is equal to y and theta is equal to dy by dx. What we will do is that we will, at x is equal to a, we have deflection is equal to y, deflection, and at x is equal to a, we have dy by dx is equal to slope. So you can see you will have this equation 2 as well as 4 and 1 as well as 2. So 1 and 3 equation is for slope, while 2 and 4 is for deflection. Clear? So you will have to put x is equal to a in equation 1 and equation number 3, and you will equate them, because you can see the left hand side of this equation 1 and 3 are same. So you can equate them and you can put x is equal to a. So when you put x is equal to a in equation 1, so it will be equal to 1 over 2 RA into a square minus 1 over 6 W a cube plus C1, and that will be equal to this term, which is equal to 1 over 2 RB into L minus a whole square plus C3. Here, okay, so you have this equation C3. So okay, so L minus A is equal to, as we know that L minus L is equal to 3A, our length is equal to 6, so L minus A will be equal to 4, which is equal to 2 times A. Clear? So here L minus, instead of L minus A, I will write 2L. Clear? So this will be equal to 1 over 2 RB into 2A whole square plus C3. And this will be the same, which is 1 over 2 RA square minus 1 over 6 WAQ plus C1. So this C3 will be equal to, this C3 will be equal to C1 plus 1 over 2 RA square minus 1 over 6 WA cube plus 1 over 2 RB into 2A square, 2A whole square. And if you further simplify it, it will be equal to C minus if you further simplify it, it will be equal to C1 plus 7 over 12 WA cube. Clear? So C2 in term of C1 has been calculated. Clear? What we will do is, again we will repeat the same process, that at x is equal to A, we have deflection is equal to y. And we will put in equation number 2 and 4 and equate them, because the left hand side of both equation is same. So again, if you put x is equal to A in equation number 2, so that will be equal to 1 over 6 A cube minus 1 over 24, 1 over, this is 1 over 24 WA4 clear plus C1 into A plus C2 is again 0, so there is no need to write C2. Clear? This will be equal to this, and this will be 1 over 6 RB into, again L minus x is equal to 2A, so it would be 2A whole cube plus C3 into A plus C4. Okay. You can put the value of C4, again C4, C3A and C4. Okay, C4. So C3 in term of, let me check this, this is 1 over 6 RAB 2A whole cube, clear, and C3 is equal to minus C3, this, where is C3? Okay. C4 and C3. Okay. So you can put the value of C3 that is C1 plus 7 over 12 WA cube, and C4 as minus C3 times L1, and again C3 is also written in term of C1. I will just write it and then rest you will do it by yourself. So RB into 2A whole cube plus C3 into A, and C3 is equal to C1 plus 7 over 12 WA cube into A plus C4, and C4 is equal to minus C3 into, so in term of C4 I will write minus C3 into L, and again C3 can be written in term of C1. Clear? That is 3 times C1 plus 7 over 12 into WA cube. So you can put the value, and I will just write it that you will get at the end, you will get C1 is equal to minus 25 by 72 WA cube. Now you can see that you have C1 value as well as C2. So you can put it in equation number 2. Clear? So you will get the equation of deflection as well as in equation number 1 to get the slope. So what we will do, that is we will use for x is greater or equal to 0 and less or equal to a, the equation of deflection will be EI into y is equal to 5 over 36 WA x cube minus 1 over 24 WX4 minus 25 over 72 WA cube into x. How I will show you that RA, you can put the value of RA and C1 and C2. So when you put it, you will get this equation. Clear? And again you can also put the value of C1 in equation and RA in equation 1. You will get the equation, this equation, EI into dy by dx will be equal to 5 over 12 WAX square minus 1 over 6 WX cube minus 25 over 72 WA cube. Or you can take the derivative of this equation to get this. Clear? Now this is, if you divide both sides of this equation by EI, you will get the equation of elastic curve that can be used for finding the deflection. And if you divide this equation on both sides by EI, so you will get the equation of slope for x is greater than 0 or equal to 0 and less or equal to a. Clear? You have the values that is given in the given data. So from given data, you have W is equal to 50 kilonewton per meter. So 50 into 10 raised to power 3 Newton, Newton into meter. Clear? A was given as 2 meter. Clear? E is also given as 200 gigapascal. So 200 into 10 raised to power 9 Pascal. There it was given that W, let me check it, W310 W310 by 38.7. Clear? So you have to go to appendix 4 of this book, which is available at the end, and you can find I is equal to 85.1 into 10 raised to power 6 millimeter 4, or you have to convert it into meter. So 85 into 10 raised to power minus 6 meter 4. Clear? Again there is EI, so better is that you multiply E with I, so you will get this value as well as, so EI is E into I is equal to 210 raised to power 9 multiplied by 85.1 into 10 raised to power minus 6, so it will be equal to 7.02 into 10 raised to power 6 Newton into meter square. Now you have all the values. Let's say this is equation A and this is equation B. Clear? So in part first A, it was given that to find the slope at point A, clear, which is at x is equal to 0. So put all the values in equation B. Clear? So when you put x is equal to 0, so this term will be 0, this will be 0, and this will be theta A. So EI value is 17.02 into 10 raised to power 6 and 10 raised to power 6, and this dy by dx is equal to theta A. So this x is equal to, this term will be 0, this term will be 0, and only we will have minus 25 over 72. W is 50 into 10 raised to power 3, and A is 2. So 2 cube. So when you solve it, you will get slope at point A is equal to minus 8.16 into 10 raised to power minus 3 radian. Clear? It means theta is clockwise. Now in part B, it is given that you have to find the deflection at point C, which is at x is equal to A is equal to 2 meter. So put all the values in equation number A. So when you put x is equal to A, so this will be EI will be equal to 17.02 into 10 raised to power 6, and it will be equal to YC, because deflection at point C is YC, and 56 over 5 over 36 W A4, 5 over 36 WA4, it will be equal to minus 1 over 6 minus 1 over 6 WA cube, and minus 25 over 72 WA cube. Clear? So you have W value. Let me also, if you simplify all these values, so you will have, sorry, one more thing, it is A4, sorry, this is 4, A4, so this will be 4, and this is A cube, and this x will be A, so it will be also 4. Sorry. So when you simplify this term, clear, so you will get minus 1 over 4 WA4. Clear? Now you can put the value of W and A. I will put it 17.02 into 10 raised to power 6 YC is equal to minus 1 over 4, clear, minus 1 over 4, and W is equal to 15 to 10 raised to power 3, 50 into 10 raised to power 3, and A is equal to 2, so 2 power 4. So when you solve this, so WC will be equal to minus 11.75 into 10 raised to power minus 3 meter. Or you can say that YC is equal to minus 11.75 millimeter, or YC is equal to 11.75 millimeter downward, clear? So this was answer of part A and part B. I hope you have enjoyed and learned from this video. Thank you for watching.